Here's another approach to create a 3D model using the beam layout that is generated in AutoCAD and importing the same. And in order to do so, go to File, say Create New, provide a name to the model, let's say again Demo 01. Now instead of defining the grid's X and Y direction, just define the floors and then accept. Now come back to an editor where you would have both the column locations and beam locations. So for now we'll just take the column locations, which are the X and Y for each of the columns at a given level. So select this, Control C in an editor, and select this option, which is the definition of column using the tables. Click on it and now say copy from clipboard. So all of the values that are there in the editor is now transferred to the dialog here, and now say accept. You can see that the column positions are now made available here at 0 level. Now go ahead and create the grids in both the directions, which will be the intersection of all of the column locations. Make sure that you can copy over all of these column locations through and through for all of the levels. So in order to do so, click on replicate option, select all the levels, select nodes and columns, and now select all of the elements and accept. If you switch to the next level 3.0, you can say that this is the column location. So now we have imported the column location. Once you have the column locations available, now go ahead and say File, Import, Beam Layout. Browse to the file location. Now we'll take it as sample 00. Make sure that you provide the correct set of units, either in millimeters or meters. The file that we have is in meters, and all of the beam layout or the lines are in the layer default, and this is the tolerance, which is indicating that anything less than 0.05 meters the lines would snap, or the endpoints of the beams would snap to that particular tolerance. Hit the key preview, and that is the beam and the nodes that are imported, or rather in preview mode. And once you are okay with the import or the preview that you see here, then you can go ahead and click the button import. You can see that the beam layout is formed on top of the existing model where we had all of the columns. If you take a look at the 3D, you could see that the beams are all generated only at level 3.0. So now let's come back to level 3.0 and make sure that the beams are all generated. And once the beams are all generated, you could go ahead and generate the slabs. So in order to generate the slabs automatically, click the generators and click the option slabs, and you can select either the FCK or the thickness. You can edit the values here, but by default the values of thickness and FCK are derived from the model defaults. You can only edit the imposed load and the uniform load while generating, and click levels that you want to generate. Since we only have the beams and nodes at level 3.0, we will only create it at the current level. Once you accept, the slabs are generated, and here is how the load distribution occurs. And if you would now want to go back and see what are all the loads at each of the slabs, you could see the dead load is 4.75, which includes the self weight plus the floor finish. And once the slabs, beams and columns are generated, you can now go ahead and create the masonry wall. To create the masonry walls, click the option here, create masonry walls, and either you can specify the uniform load in kilonewton per meter, or you could let the system automatically determine based on the available height and the width on the given beam. So for now we'll just go ahead with the default options, and I'll select all of the peripheral beams. So those are the peripheral beams on which we are loading the masonry walls. And for all of the interior walls, we can just go ahead and say the load is maybe 5 kilonewton per meter. Select every single beams that are around there, which will have a partition wall, and say accept. Now that we have the slabs created, beams generated, and all of the walls generated, now you can go ahead and make a copy of all of these elements to the next higher levels. In order to do so, select replicate from the current level to all of the remaining upper levels. We don't want to copy it to the foundation level, which is 0.0, and we want to copy all of the elements, and we want to select every possible item that is there on the screen. Now say accept. If you switch to the higher level, you can see that the items are all copied. As you can see on the upper floor, the masonry walls are not copied. Here the users will have to explicitly provide the wall height and recreate the masonry walls. And here is how it looks in 3 dimension.